Hello, welcome back to the channel. Let's solve another challenge today. Our today challenge is LeetCode 199 binary tree right side view. So we are given the root of a binary tree. Imagine yourself standing on the right side of a tree and return the value of the nodes you can see ordered from top to bottom. Before looking at the example, let's look at the constraints. So the constraints are the number of nodes in the tree is in the range from 0 to 100, and the value of each node can range from -100 to 100. And this problem is it looks like this problem is a quite popular problem, and we can see which companies asked. You can see Meta, Amazon, and Google, they ask it quite a number of times for the last 1 to 3 months, right? So let's look at the problem, what the problem is asking. So basically, problem is asking that we are standing on the right side of the tree. Let's see. This is a root. We are standing on the right side of the tree. We are just looking at the tree from the right side. See, this is a root, and root has left child and right child, and we have 5 and 4, and see which nodes we can see if we just look at this tree from the right side. We're just staring to the tree from this side, right? From the right side. We can see from the first level, we can see 1 because there is nothing blocking 1. From when it comes to the second level, we can see 2 and 3, they are on the same level, and 2 is being blocked by 3. And the next level, third level, we can see that 5 is being blocked by 4. So what we need to return, so from the first level, we're going to return 1. From the second level, we're going to return 3. From the third level, we're going to return 4. So that's what we're being asked. So in the next one, the same thing, we are just looking at from the right side. You can see it can be left tree, or it can be the right tree, right? So look at change the color. So it can be the left child or the right child, right? And if we're just looking at from this right side, from the first one, we can see there is nothing blocking that. The visibility from the second, there are 2 nodes in here, right? 2 and 3, right? If we just look at from the side, we can see only 2, and this is blocked. So the 4, there is nothing to block from the right side. So 4 is, we can see, and 5 is the node we can see because this is all open, right? But because this is the first level, second, third level. In third level, we have only 4. We have in the fourth level, we have only node 5. So what we need to return here, we are going to return from the first level, we're going to return 1. From the second level, because we're going to return this one only, 3. The next level 4, next level 5. So this is basically that's what the problem is asking. So let's see how we can solve this problem. So we have 2 ways, right, to solve this problem. Let's just erase these trees and clean up. And there is a DFS and there is a BFS, right? For the DFS, we are gonna come the first left child, and the left child is empty, and the right child basically will just iterate like this, right? With DFS, depth first search, right? That's a recursive approach. And the same thing here, we just come like this, go through and just come back, and just this is DFS. That's how we look at. So intuitively, there is another way, that's BFS with the level or the traversal. So what happens is we start from root, and each level we go, right? Then we come to this left again right, right? And when we traverse by level and we collect the nodes, we collect each node in the level. Then here 5 and 4, same thing here. Either we can do DFS or BFS, but intuitively again BFS is much easier. So we go here 2 and 3 and 4, and there is nothing. Again 5 and there is nothing, and we collect all of the nodes. So we can use BFS. That's much more intuitive and easier to explain. Also, then with the BFS, it's a BFS level order, right? Level order traversal. So what happens here? We initialize Q, right? We initialize Q initially. So we take the root node to the Q. So it's DQ root node. We add the root node to the queue. Then for each, now we can close this. So for each level, what we do, we collect them, right? We collect for the first level, we collect 1. For the second level, we collect 2 and 3, all the nodes, right? And after we exit that level, for example, this level, right? When we exit this level, we return 2 nodes. Let's say 2 and 3. Initially, actually, this is not. This can be right, but I would like to add 3 and 2. First, I would like to add 2, and because that will be added to the queue. Then 3. So from the after I'm done with the first level, so we have just 1, and the second level we have 3 and 2, right? And after the third level we have 4 and 5. So this is the list of the nodes in the first level, and this is a list of the nodes in the second level. This is a list of the nodes in the third level. All we need to do, we need to return 3, we need to return 4, right, from here. So we need to get this level list. So we need to return the 1 from here, right? Then we need to return 3 from here. We need to return 4. So if we just see this, if this is a level, like the level is say 3 and 2, what we need to do, we need to get the first element, right? To get the first element is just a level 0, right, in the list. So this will be added to the output. Output will be, initially we're gonna initialize output append level 0, right, from each level. So this may not be that clear, but hopefully when you see the code, it will be much clearer. So so this is a simple BFS traversal, level order traversal. So I have other problems we already discussed in the playlist. So you can look at those problems too. But once you see the code, hopefully the things will be much clearer. So let's write the code. So here initially what happens, if the root is none, so we need to return empty list, right? Then we're gonna initialize the queue. We'll initialize the queue, dq, and we put the root inside the queue. Then we say output, we initialize output to be empty list, and we iterate the queue. While queue is not empty, then we get the level size. Level size is equal to length of the queue, right? Then for the level, we initialize for each level, we have to initialize the empty list. Then we go for, we iterate through the queue for each level, right? For in range level size, then we pop the node from the queue. So node is equal to queue dot pop left. Then we add this node we append this node to the value of the node to the level. Then we need to add from that level, from that node, if the left node exists, if the left child of the node exists, then we need to add this. Let's add first the right node. If the right node exists, then we need to add this to the queue, node right. Right, then if we do the same thing, if the node left exists, then we're gonna add the queue append node left. So then after we are done with this, then we exit this for loop. Then we add to the output append for each level. What we need to get the first element in the level list. Then here we need to return the output, right? So let's submit this this problem. Okay, so it's accepted. Okay, yeah, so that's the solution for this problem. So the time complexity of this approach is O of n. N is a number of nodes. And the space complexity is we are only keeping the list to collect the number of nodes in each level. So M is the maximum number of nodes in each level. So this is a simple solution. Yeah, please comment and share your thoughts and questions. And I'll see you guys in the next video.